Hello, welcome back. So in this video, we're gonna talk about continuous replication in Postgres, but I would like to set the context of this video. As you may notice, I will be working on the right side, assuming that we have two servers that is managed by the system manager, and those servers are connected to AWS, which is optional. Not everybody needs that. We know that the majority of our business or the majority of application run on cloud, but in terms of performance, if you are working on a large application with a bunch of reads and writes, you wouldn't have one server. You would prefer to have two servers, okay? But it's pretty simple to set up on AWS. With few clicks, you can set up the asynchronous replication with Postgres RDS. Now, in this video, we're gonna work on the on-premise. We're emulating the server A being the primary server and the server B being the standby server. Just to set the context. So without further ado, let's go to the demo and demonstrate how to set up a continuous replication in Postgres 14. I'll see you in the demo. Okay, let's start our demonstration. So as you know, we are working with the vagrants, but the requirements for this video is that you need to have a knowledge on continuous archiving. If you have not yet watched the video on continuous archiving, or if you know how to do continuous archiving in Postgres, you're good to go for this demonstration. Before we get started, we need to start both of our server, the primary server and the future secondary server. So let's cd onto where we have our vagrants file, documents, postgre list. Yeah, we can see we have our vagrant file right here. So with that, we can start our servers. The primary server name Simbulu and the secondary server name Kambove. Okay, Vagrant is starting our servers. I'll take a pause here and then I'll be right back when all our servers are up running. I'll see you in a second. Our server is up running. So let's SSH onto each one of them. Vagrant SSH Simbulu. So we are SSH onto the primary server Simbulu, and then we're gonna SSH onto the future secondary or standby server. Okay, vagrants SSH to Kambove. Okay, next thing we need to do, we gotta confirm that Postgres is up running. So etc init the Postgres status. So Postgres is running on Simbulu, our primary server, and let's verify that Postgres is running on our secondary server. So sudo service Postgres status. Okay, it's also running on our secondary server. Okay, now we are going to configure the primary server to replicate any change made on the database onto the secondary server. To start, we are going to use a utility in Postgres called base backup. Okay, so we're gonna use the PG base backup in Postgres to create the base backup from which we are going to launch our secondary server. So as you can see on the documentation, if you just issue the command pg base backup -l, you will see the documentation. If we pass the parameter pg data, we have to specify a valid file descriptor directory where the directory will be created. We have the format, which with verbose -- format. What else? We have one of the most important parameter. We have the write recovery configuration, which allows us to have the configuration file from which we are going to launch our secondary server to be able to replicate data from the primary server. Okay, let's verify what we have on on secondary server. I'm now on Kambove, which is the secondary server. Kambove server. So we need to verify its status. Sudo user Postgres PSQL database Postgres. Okay. As we can see, if you're trying to list any relation, there is no relations. Also, if you try to connect to any database, our default database person from the primary, we don't have any database named person. So which means as of now, this database has not been configured, as being a secondary server. To confirm that, let's quit. We can check the status of the cluster. Sudo systemctl status Postgres at 14-main.service. As you can see, a check pointer, background writers, which means it's not a secondary server. It is a primary server because it can write data, or it's a world writer, so it can write the write ahead log file. Okay, we want to make this server, the Kambove server, being our secondary server just in case. Cool. Now let's go back on the primary server and use our PG base backup to create the base backup from which we are going to create the standby server. Okay, we want to make sure that the backup will be easily accessible by the secondary server. Just in case you are using real physical two server, you're just gonna copy your backup and then go run it on your secondary server. Okay, but in this case, we do have our share folder, cd-pg backup driver, from which, as you can see, we are writing a war file, the write ahead log file from the primary, but we need to make the backup somewhere here because Kambove, as our secondary server, can also access the share folder. Okay, Kambove can also access that, so we want to make sure that we create a backup on this share folder, and then Kambove will access that and then copy that so we can configure the standby server. Okay, let's go. We are going to use PG base backup. Okay, but if we just use PG base backup, we are going to run PG base backup from the Vagrant user. We want to make sure that every file we'll be creating from this utility will be accessible only by Postgres user. You can either just do sudo -i-u Postgres, so you can set yourself as a Postgres user, but I don't like that. I don't think, it doesn't really, it does change coloring on the terminal, so I still need coloring on the terminal. Okay, so therefore we need to use this one, sudo user Postgres, which means we are going to run our PG base backup as user Postgres. This is really important because if you run it as Vagrant or any other user or root and you copy that file on your secondary server, you stay there for years. Okay, let's PG base backup. The first parameter we need to pass is the format. Now let's use the PG data. PG data is our directory, what is the name of our directory and where the directory will be located. We want the directory to be located in this driver, shared driver, PG backup driver. So // here, and we name our base backup for the base backup dash to dates 2023-02-20. Okay, the next parameter will be the format. We want the format to be a tar, which is a compressed file. Next one, we want to use a gzip compression, so gzip, and of course the compress level 3. We're gonna compress that in level 3. Next, we need to tell PG base backup that, hey, this backup you're running now, we are going to use that to create our standby server. So make sure you include in this backup the recovery configuration. Okay. Next, we need to define the whoa method. So what's gonna happen as we are doing the backup? So if we pass dash dash whoa method, or this tells Postgres that you can continue doing, or you can continue streaming whoa file or the write ahead log file while we are doing this backup. Okay, that's the meaning of this parameter. Next, we wanna deal with the checkpoints. So by default, when you're doing a base backup, Postgres waits for the next checkpoint before it creates your backup. So we wanna tell Postgres to do it fast, right? Yeah. So we are telling Postgres here, don't wait for the next checkpoint, just do the backup. Okay. Next, we have the no sync. So what does no sync tells us? So no sync means that when you are doing a backup, don't wait for the next WAR file to confirm writing on the disk before doing this backup. Just do the backup. You know, don't confirm that the file has been written on the disk. You know, just do the backup. Okay. Next one that is really important. It's optional, but I think it's important. The label, you know, this label Postgres we use that, you know, while restoring or to make it, you know, a distinction between this backup and the next one. Let's name that base backup person. Okay. The next one we have a progress. We want to see the progress as we're doing the backup. Postgres will show us what's happening when the backup is in progress. Okay. Of course, we want it to be verbose. Next, we have the username. The username we'll be using here should be a super username. If you use any regular username, they won't be able to access properties of PG backup. So there should be a super username. We're gonna use the Postgres, and we need the database string, which is Postgres localhost 5432 from person. So we are backing up the cluster database from the context of the database person. Okay. Now we need to type our password, the password of Postgres. Remember, we've changed the default password of Postgres. That's recommended when you're doing any configuration of your database with Postgres. Cool. Let's type our password. There we go. Let's try that again. Okay, now it's working. There we go. So we've successfully create our backup. Let's see the results. As you can see, we have a new folder named backup dash today dates, right? Okay, let's see what is inside of this folder. Now we have the file backup manifest. The backup manifest, let's see the contents cut. So I need to use a Postgres backup cuts backup. Okay, it's just a JSON it's a JSON file with some checksum and path from which we can verify our backup. So there is another utility called PG verify backup. You can use the against this JSON file to verify that the backup has been successful. We're not gonna talk about that today. And we have our base. This is the base backup. It contains file that we'll be using in our secondary server, so we may configure the standby server. Of course, we have the PGWO that contain the last record of WAR file. Let's see. Let's try to extract PGWO and see what is within. Sudo user postgres PG whoa. As you can see, it's just a sort of checksum number, thing, which means this file is the one that we'll be using in our PGWO onto the secondary server, so we can be able to configure and replay what's been happening on the primary. We will see how it works. Okay, so we have our backup file name base backup, and if you notice, that file has the same number as this one, like a 00053. Okay, so now let's import our base backup onto the secondary server and replay that so we can start configuring the standby server. So we are now on Kambove, our Kambove server, our secondary server, and let's cd onto. We need to set ourselves in the context of super user so we can access the data directory. If you want to see where is your data directory in any server, Postgres server, do the following: sudo nano the Postgres main Postgres config. I'm using Nano, so if you want to set something on Nano, we use Control W, and type data directory. Okay, and our data directory is on var lib Postgres 14 main. If you are really serious about how critical your database is, don't use the defaults, because there are some people calling themselves the best hacker. They just use the defaults one. If they get access via vulnerability of sudo, they will just use the defaults. But this is more advanced. We're not gonna talk about that today, but this is where your var lib Postgres 14 main is located. And that's where we're gonna modify our data. Okay, keep that in mind. Let's exit. Remember, I didn't save anything. I didn't make any modification. That's all we need. Now, let's go to that directory. We can only access that if you are super user or if you are in the context of Postgres user. So cd var lib Postgres 14 main, and that's our main data. That's our directory data. We are going to delete everything that is directory. Yeah, I know what you're thinking. You're gonna crush it. Yeah, that's the way it works. We got delete everything and replace that from using the data coming from this directory base.tar. So we're gonna replace everything extract from this directory onto this folder. But I make sure that you may still need some of the PG record. As CD, I'm not here. So if your database, if this database as a standalone or as a isolated primary had a lot of record, and all of a sudden you want to make him become a standby server, you will see there will be a lot of WoW record here. So keep that. And then if you need to keep that, you may keep that and then reuse them. When you're gonna replay, you will merge data from the primary to, which is really dangerous, but it can be done. And then you will see keep your data while synchronizing from the primary. That's another topic. But we're not going to talk about. Just the heads up that you need to make sure that your PG world records is needed or not. Okay. Now, it looks like we don't need that. Yeah, we don't really need that. So what I will do, I will remove any pg star folder to remove, and I'm also gonna remove any base. I'm gonna remove this base directory. And global. Okay, let's remove them. What else? We don't need, let's see the contents of Postgres auto config. Cats. Let's clear screen. Cats Postgres auto config. Nothing, so we don't need that. We're gonna use the auto config file from our backup from this guy. So we don't need that, which means we need to remove that Postgres. What else? PG version, we're gonna bring some, post master pid process ID, cut post master. We really don't need that, since as you can see the record here, we are dealing with localhost, whereas we now be connecting with localhost. So I'm gonna remove that. Post master, remove post master process ID. Okay, we need this file, make sure you keep that. You may remove that if you are sure it's gonna be included from your backup, but you need to make sure you keep this file. I'll show you why. Let's see the contents. Post master. This file will help us set up the cluster, so that the cluster on this secondary server will be in tandem with the cluster, will be unique with the cluster on the primary server. As you can see, the var lib will point to 14 main, and the config will point to the config name. We need that. Okay. Now let's copy base star. Let's copy this guy, base star, this guy, and this one onto our data directory. So to copy them, we need to set ourselves in the context of Postgres, be Postgres, so that when Postgres is doing that, all the file we have permission of Postgres. Okay. Now copy pg backup. This is our share folder. If you have your share folder in the network, you're gonna use that. If not, just use a flash drive. What are we gonna copy? We can copy recursively, or we just wanna copy the base dot star, the compressed file. Base backup, base.star.gz, where we're gonna copy it. When I copy, the destination will be here, just a dot. There we go. So we got our file. Now we're gonna extract this file here on the main, which is our data directory. So let's first verify that base backup permission. You can see Postgres is the owner of base star. Now still we need to use Postgres as well, because if we extract that using just star, if we just use star, we assuming that we're using the roots, and we don't want this extract file to be with root permission. We want it to be on Postgres permission. Okay, sudo user Postgres star -x, which means extract, f the file, base star. Let's go. I didn't pass the verbose. We don't want to see what's happening. Let list, as you can see, it's pretty similar, right? It's almost the same file, but we still need to get something right here. As you can see, we have the Postgres auto config. That's the parameter rights recovery config that we passed when we were creating the backup. It's create this file for us. We have the standby signal. This file will instruct Postgres to instruct the cluster to recognize this server as a standby. Okay, now let's do some modification on the Postgres autoconfig. Since we've used our Postgres user to create a backup, we didn't use any other user. And we did the backup in the context of pointing, I should say, we use the backup pointing to the local host, right? Let's see the contents. If we see the contents of Postgres autoconfig, now here we have, critical information that will allow us to create the standby server so the standby can connect to the primary. We have the user Postgres, right? We have the user password. But if you can see the host is local host. We don't want the host to be on local host. We want the host to be on the primary server, the IP of the primary server, or the domain name that's pointing to that IP. So which means we need to modify this. If we don't modify that, we're gonna sort of creating a loop. It will be searching for change on itself and it will never become a standby server. So with that, sudo user Postgres nano, what's the name of the file? Postgres config permission deny. I don't know why you deny permission, but it's a Postgres file, so we're gonna force it. Okay, now let's change this IP to I would like to use the IP instead of using the name so I cannot create any confusion. So let me use the IP 192.168.56.4. That's the IP of the primary server, not the IP of the standby server. Remember that. That's all we need. Of course, we don't need this base star, so leave it or remove it. I'll remove that. Base star. Okay, so we got everything. What's next now? We just need to restart the server, right? You can exit. We prefer that you stop our service Postgres stop. So we stop the server and we start the server again, or just use restart. So you will see it takes a few seconds, which means it's making sure that our configuration is being applied. There are certain configuration we still need to do on the Postgres config file, but let's see what it does, and I'll show you what's next for us. Okay, so now let's check the status. Postgres is running. Now let's exit and let's go check the status of the cluster. System etl status Postgres at 14 man. So you can see